Each element comes in 2 or more flavors. For example, there's carbon 12, there's carbon 13, and there's carbon 14. Each of these types of elements is called an isotope. So, there are 3 isotopes of carbon. Now, first note, if you have 6 protons, you are carbon. And if you have 1 proton, you are hydrogen. So what this means is the atomic number determines who you are, and atomic mass determines how heavy. So, for any given element, we're going to have lighter versions and heavier versions. Heavier in what way? How can they be the same but different mass? Well, they have the same number of protons, but they have a different number of neutrons. Or to look at it another way, they have the same number of protons and a different atomic mass. In addition to carbon, another example is hydrogen. There's a hydrogen with no neutrons, there's a hydrogen with 1 neutron, and there's a hydrogen with 2 neutrons. As an aside, these are very, very important isotopes, and they're actually given separate names. Now, one thing you might notice from looking at a periodic chart is every atomic mass has a fractional component. Well, how do you get a fraction? If you have an even number of protons and neutrons, or an integer number, how can you get a fraction here? Because this fraction arises because the way it's determined is taking the average of the isotopes. Well, let's take a look at how atomic weights are calculated for the periodic chart. Now, you won't have to know how to do these calculations for the exam, but you do have to know how it is that it comes about that the atomic weights are not whole numbers. So let's consider the 3 isotopes of carbon again. If you found some carbon in nature and you plucked out the isotopes and counted them, you would find out that 98.9% of the carbons found in nature are carbon 12, and 1.1% are carbon 13, and only 1 part per billion are carbon 14. So how this 12.01 is calculated is called a weighted average. The 12 is multiplied by 98.9, the 13 only 1.1, and the 14 only 1 part per billion. Now, based on a weighted average, you would expect the answer to be near 12 because almost all of the carbon is found in nature is carbon 12. And indeed, it is very close, 12.01. So if you have an atomic mass that is a whole number that's an integer, then you know you're dealing with an isotope. On the other hand, if you're dealing with a formula that has a fractional component, then you know you're dealing with an average of isotopes.